So, welcome to this last hour of this course, where we were trying to explore the processes and of brain and how it creates mind. And I hope it has served its purpose till now, because we took a journey from the very large level of behavior, which kept popping in every now and then we took almost a reductionist approach to understand to microscopic level, to mesoscopic level, and to not really macroscopic, because that would have taken us to universe. So, where does all this leave us? Just to recapitulate and give you a whole idea of how putting everything together. So, look at the structure: subcellular, talking about tubulins, talking about mitochondria, talking about dendrites, to neuron, which is a basic unit, right from dendrite to axon and its neurotransmitter. Subcellular obviously includes the formation of neurotransmitters. Each neuron connected to the other through synapses. Multiple neurons get organized in microcolumns, mini columns, and macro columns. Two functional cell assemblies, that Hebbian cell assemblies, whether they are located in different parts, whether they are separate from each other, but they are connected functionally. Neurons that fire together, wire together, the basic template of learning. To basic Broadman areas, the specialization of speech area, of receptive area, of visual area, of movement, motor area, of sensory area, they go on to make one hemisphere, and two hemispheres go on to make the whole brain. This is the broad structure of brain when we talk about it. And what is the process? Each neuron having neurotransmitters, either a single one of them, or there is a differential weightage of neurotransmitters while connecting to the other neurons. Synaptic signaling in the order of 0.5 milliseconds through neurotransmitters like acetylcholine, norepinephrine, dopamine, glutamate, GABA. Some of them are excitatory and some of them are inhibitory. Two, action potential, that sudden firing from minus 70 millivolt to the threshold of minus 55, and then a peak of at a single neuron level. But neurons, a single neuron does not mean anything. It has to sacrifice its history into the assembly, into the multiple hordes of neuronal network. Then the postsynaptic potential, the excitatory postsynaptic potential and the inhibitory, which summate together. We talked about the McCulloch-Pitt model of it and the Hopfield network, which are based through, which work through associative networking, content-based categorization system, and energy transmission, which create oscillations. And we know the oscillations from 0.5 to almost 500, but of our interest what we have is 0.5 to say 40 hertz, which is a gamma oscillation, the binding oscillation. So, what we know that there is a multi-level, multimodal differentiation and integration of information. So, the whole purpose of this process is a interface with the external world, where the information is taken, it is processed, it is memorized, it is categorized, it is used basically for two things, rather one thing first, that is survival, and second is obviously you have to, genes have to perpetuate the human race. So, to survive you have to anticipate the future, predict the future. So, lot of areas, lot of this information in humans, we do not know about animals, I am sure animals also must be doing it, is about taking the information and going into a mode of anticipation and predicting the future. Because if they do not, then you cannot plan, and lot of human activity has come out of this anticipation and prediction, and ultimately the behavior output. Now, as you go from neurotransmitter, which is a micro thing, a micro structure, a micro level, to the complexity of behavior. Behavior itself is very complex. and so many psychological factors, so many things go on, and I am not talking of psychology here, because this is an entirely physical process which I have explained in these two slides, entire physical process. We are not talking about the thoughts, the emotions, but they are also simultaneously affecting all this, and all these systems have a feedback thing. Behavior can alter the neurotransmitter signal, like a chemistry can. It can alter synaptic signaling, it can alter the action potential oscillations. So, this is in a huge feedback loop, re-entrant, recurrent loops which keep happening, which lead to what we call life and understanding. So, what we know that brain has a specialized area for a specific function. So, it is a modular structure, which is the spatial understanding of brain. There is a high level integration process done by the brain, but not by its part. Each part is doing its job. It is the association areas between these parts which actually create the meaning, whether it is in one area, associative area, or it is at a higher level through the default mode network, through the central executive network, or through the salience network. These various type of network, remember in the first slides we had shown you couple of these networks. The ultimate product is complexity. Human behavior itself is complex, and so is the underlying brain network. So, just to reiterate it, molecular synaptic level. So, there is a at a very molecular level, you are talking about ion channels and membrane properties, neurochemistry, psychopharmacology. Go up at a single neuron level, you find electrical compartment model, the sodium potassium inflow and outflow, and sodium potassium ATPase, the long term potentiation and long term depression, forming memory and forgetting. There is a physics to it. Neural assembly, the spikes of single neurons and the multiple neurons, we know about EEG, and as you go up, you talk about EEG and MEG and recurrent networks. Continuing to that level, then there are small networks where you have recurrent network dynamical systems. Then you have transcortical across the cortex. Then you go to larger brain structure where you are talking about behavior and cognitive psychology. Now, as you see, till a small level here, if you look at it, it is all talking about physicality of the brain. So, you see these small networks, they are all in feedback loops. If you can just look at it, see the arrows. So, it is a modular structure, but still it is a parallel processing, and while it is parallel processing, it is still hierarchical, because as you go from lower level to higher level, the whole complexity increases, and this is all connected. So, in a hierarchy, this is wonderful, because there are too many different concepts are coming, modularity, parallel processing. You are not supposed to have hierarchy, but then in parallel processing also you have a hierarchical system because of the structure, and we are not talking about the geometry of the brain still. Whether it is because of the geometry of the brain, the sulci and gyri and the way it is packed. Now, from engineering angle it is fine, because you get more space to pack more neurons, and you need more neurons to have more data, to have more information. But is the geometry of the brain in space and time is really giving the way it behaves? Not only in humans, in a lot of mammals and primates. But once you cross this transcortical level, you have to talk about, or small networks in that sense, you have to start talking about mind, intuition, psychology, behavioral psychology, and then that forms another abstract layer over the real physical process. That still is the biggest enigma, because there are a lot of things which we do not know. A mind can communicate to the mind, telepathy, people can see dreams. We talked about dreams briefly in the last lecture. What are dreams meant for? Why is this such a structure of deep sleep and dream sleep? What is the purpose? We really do not know. We have models, but still we are very far. And then, so this layer of abstract thinking has one more layer, where we talk of all psychology, spirituality, behavior, relationship, everything which goes into your life. So, we have huge information, the plethora of information, which has given us pockets of understanding of the physicality of the process. We have psychology, spirituality, philosophy. We should not ignore all this, even while we are talking of science, because it's a vast base of knowledge. We just can't reject it, which explains this abstract cloud of knowledge or emotionality and all. Where is the connection between the physicality and, so that is the big debate, like we talked about consciousness. Some people say this, that physicality till this level actually gives rise to all this, but there is a big knowledge based system which says that all this is separate. The physical theories cannot really explain that how does this abstract cloud affect the, okay, agreed, that is a electrochemical signaling which forms a pattern, and this pattern gives rise to mind and thought and everything. Agreed. It can be a jump from electrochemical activity to this abstract thing called thought, which we don't know what is the real content of the thought. How does this thought get back and affect the electrochemical firing? It does, we know. You may be hurt and you have to reach somewhere, but you can still put your will to really go there. So, where does this will? Does this, is there a center in the brain which has will? We don't know. So, the same electrochemical activity creating a will, which is sort of a cloud, if you think that way, but how does this cloud get back to electrochemical activity? There is a big gap. This gap is still, so we know pockets where we can do a lot of utilitarian activity. We will discuss about this as I move on. So, what I want you to do in this next 30-40 minutes, whatever we have, is think. You have to think now, because I am sure that if you think, some of you may really pick on the thread and take it on to the next 50 years of research. It is a very interesting time in neurosciences. I just put this theoretical model of brain on Google today, and these are the results I found in 0.48 seconds. So, you can just imagine the amount of work which is going on. Now, some of them, this may be repetitive, but still if you look at the basic models, still there are many. So, what has happened? It was biology and psychology which was working till about 20 years back, maybe 30 years back, and suddenly people realized that physics and chemistry and computers and everything has to get in, because computers were being modeled on the brain processes, the way brain works, especially with people who work in artificial intelligence. So, what is the physics of brain? Is it a quantum physics? A lot of people have worked on this. A lot of people are criticizing. I will take few names. Maybe you can find out the original differences. There is a guy called Roger Penrose. He is a great mathematician, Hawking's colleague, and he has written 2 books, Shadows of the Mind and Emperor's New Cloth. Find out time to read that. He and Stuart Hameroff, who is an anesthetist, they talked about quantum processes at the level of microtubules, which is a subcellular structure, and the quantum tunneling between the synapses. People like Max Tegmark, who has written a new book called Our Mathematical Universe, criticize them because just of the time scale. We have talked about it. Chaos, Walter Freeman, Errol Bessar, they were the people who were talking about the non-linear. They were very popular around 95 and 2000. It actually went out of fashion with this quantum thing coming in, but the non-linear dynamics in the brain is a reality. And these are type of signal analysis which you do. If I get time, I will briefly show you what type of signal analysis, because you do all this non-linear thing, dimensional complexity, attractive dimensions, exponents, Lyapunov exponents, this type of stuff to know where. Now, see the difference. Some processes are trying to look at the basic microscopic, again this scale difference. So, this scale thing is a big problem in studying. That is why probably a comprehensive theory is not being able to come out. Quantum, we are talking at a sub-microscopic scale. Non-linear dynamics is talking about the whole dimensional complexity of the brain. Then there are systems like, where people have studied like Hamiltonian model of brain. There is a theory by Baars, B-A-A-R-S. He has written a wonderful book you can find out on the net. It's called global workspace theory. Remember the picture which I showed you while talking about consciousness? There is a huge unconscious and there is a conscious thing, the whole buffering of sensation and going to central. It is a global workspace in the brain which is arising from the electrochemical activity and the neuronal network, but like a workspace is like an envelope over the brain. And then there Bayesian probability thing, you know Bayesian probability that it uses the present the present dynamical state to check the probability, to check the possible routes which it can follow. Then there have been papers on free energy models, Hamiltonian I already told you, entropy, second law of thermodynamics. The brain is a warm structure, it is not a cold structure, and it is not fully closed, neither fully open. But still does brain have entropy, which may lead to, and at the same time entropy causes disorder, but the brain at the same time is very, very homeostatic organ. It tries to remove ambiguities, uncertainties and bring the whole system back to a resting state. But this dynamics of disorder and order. Then there is a small scale network theory which has been brought up by Strogatz, which has been applied to the brain, slightly appears to be small, but then there is a large scale network theory also. So, the thing which is popular these days is brain being studied on networks, the graph theory. And one of the popular thing is connectomes, brought out by Olaf Spons. Connectome is a model which has been given that brain has nodes, like any network, they have nodes and they have edges which is connecting. So, based on these nodes, then there is a huge number of models which are coming up. But again, the problem is when we study all this, either we made a theoretical model and then try to do experiments. But why? How do we do experiments? Maybe I make a theoretical model of all what is going on in a brain in a given instance. How are we going to check it? We again have to resort back to the microscopic single neuron. Does it work? No. Intracortical recording, does it work? No. EEG? Yes, but EEG does not give you the spatial thing. So, MRI? MRI is all task dependent, PET is task dependent. So, moment you give a task, you already restrict what you call a region of interest. So, again your whole brain is gone. So, that is the big difficulty of uniting the spatial temporal in a given instance and then extrapolating it to the whole brain functioning. Whole brain functioning is so complex because each area is doing different things. How do you unite it? And you see the number of papers. So, where do we stand? Let me take you back, many years back, 5000 years back. I am next to river Vyas. You would have heard of Vedas, Rig Veda, Sam Veda, Atharva Veda, Yajur Veda. I think they were very smart people. Very smart, but still they would have realized the futility of possession. So, we do not know who wrote it. They never put their name into it. After writing the whole Rig Veda, which is a sort of way of life and worship and everything, there is a 10th mandala in Rig Veda, and this is something called Nasdiya Sutra. If you really trace history in a very, very secular form, that is the first skeptical inquiry of existence. And I think cosmology, physics, even quantum physics to some extent, and all the neuroscience is still groping with this question. Maybe the answers were not there, answers may come from us and our times, but the questions were right. After writing all this, they wrote something called Nasdiya Sutra. I am just giving you an example. Some of you, I do not know whether some of you who were there in 1990 and were conscious enough would have seen Mr. Shyam Benegal's serial called Discovery of India. If not, please get a DVD and see. It is available on YouTube also. It starts with Shrishti se pehle sat nahi tha, asat bhi nahi. Before the creation, there was no truth, there was no falsity. छिपा था क्या कहाँ? What was hidden where? So, I am just translating it. This is one of the shlokas of it. Then even nothingness was not, right before Big Bang, maybe, if you want to fit in. What was there before Big Bang? Nothing. There was nothingness was also not there, nor existence. There was no air then, nor the heavens beyond it. What covered it? Where was it? In whose keeping? Was there cosmic water in depths unfathomed? So, after writing all that, the way of life and worship and all, they questioned all this. The origin of universe. These questions still actually haven't been answered if you look at it. Especially when you talk of multiverse, you really don't know whether we have our Big Bang was no Big Bang. Who knows? The fantasy theory is that if there are black holes in our universe, there must be black holes in other universes also. Whether we emerge from some black hole from the other side. It may sound crazy, but believe me, people when they sit alone, they ask these questions, because all is theory. You can't go back and prove a Big Bang. But because we have excellent explanations in quantum and other cosmology thing, there is a possibility, but still lot is to be explained. So, when it is lot to be explained in the universe, mind still is. So, what is real? Let us ask this question. I told you about that you do not become conscious before 200 milliseconds, and your unconscious mind is presenting whatever it has to the conscious mind. Is it 500 milliseconds of frames? That everything you are becoming conscious of 500 and you think it is reality. Unconsciously you do not know what is happening, you only know what is happening in your conscious mind. But when I am seeing this, when I am looking at this recording, whether I am seeing it in the way it is, or it is my mind which is creating it. So, whether it is just 500 milliseconds of reality and everybody has their own reality, possibly we think what is normal is because everybody is thinking alike, because the same set of stimuli which is going on. Suppose we change the whole presentation every second, then will the reality remain the same, or it is whatever image comes to the mind and the meaning given to it. Because what I see as red, you may not be seeing as the red, although you may agree it is red, but that is the quality of brain, because it handles symbol. A certain color has been given a name called red, and that red is what we believe. But where are we seeing the same red, you and me? Are we seeing the same? Are we, when the wind blows, that is a physical quality. Are we feeling the wind in the same way? We don't know. So, is it the meaning? Because the wind blowing may mean 100 things to 100 people. And that is why I say that is our uniqueness. So, your brain is handling the same symbol in a different way, whether it is the physical movement and sensation or the thought and emotion. What is the real? A touch is real, or the meaning of that touch is real. A meaning of the same touch may appear different to different people. When people are in love, the touch sounds very good. Everybody wants that touch should stay. And imagine the same people when they have married for 10, 15 years, and when they are angry or fighting, the physicality will be the same. It can't change. But the same physicality, people will get irritated. So, what is happening? Is it your mind state? Mind state in the sense that, okay, you are happy, you want to be with somebody, and then you feel like it's good. And on another occasion, you are irritated, but there is the same chemistry in the brain. So, is it you have given the meaning, or you have added some value addition to it. You have done a top-down thinking, decided, okay, this is my lover, the touch is good. And then you are top-down thinking that I am angry. So, you already told yourself. That is what I told you about, that how does our mind, even before, objectivity in mind is very difficult. Consciousness emerges from what we call about the neural correlates of consciousness. That is the brain electrochemical functioning and network. But as I said, how does consciousness affect? If consciousness is like a cloud or an abstract envelope, how does it affect? Because electrochemical activity, is it what? And also the big question is, these patterns of electrical firing, how they really coalesce into making an image, and who is seeing that image? There used to be a homunculus theory that is a little man sitting inside the brain who sees all these images. But then who is seeing that little man? So how many little mans will be sitting? So we don't have a homunculus, one screen. So are there multiple screens in the brain with images are being reflected and one of them finally decided? We don't know right now. And if they are created like this, if an image is created in a brain, how do you see it? Or you agreed you see the external thing. How do you see the internal thing? And where? So is it a field, electromagnetic field, or is it just electrochemical activity? So let me add more confusion now. What is self? If in the non-dominant, left is dominant in a right-handed person, in a parietal lobe damage in the non-dominant hemisphere, if there is a damage, there is a concept of self is gone. There are people who will have paralysis, but they will not recognize it as their own. There is something called anazogonesia, where people do not recognize their, that is what V.S. Ramachandran keeps working on. And parietal lobe damage leads to the whole. So possibly because I told you about the stream of stream from visual and auditory, which is telling you what and where, that totally orients you, and the binding oscillation probably binds all the information coming into this self and gives you a concept of I. But the image of self is also disturbed in schizophrenia. If you remember, I told you about the internal imagery and the external imagery. What are hallucinations? Hallucinations are perceptions without the stimulus being present in the external environment. So internal imagery is being projected, and this person believes that. So the boundary of self is broken. Some schizophrenic patients feel that their mind is being controlled by somebody else, or some thoughts are being put, it's broken. Or compare an illness like obsessive compulsive disorder, where the self is preserved, but the mind cannot stop repetitive thoughts. So they become intrusive. They almost like tennis balls which are thumping on this boundary of self. So it is just integration of information, but there is more to it. A person, but then if you talk of physicality, if you should read a book called Diving Bell and the Butterfly. This person had a paralysis of all limbs. The only thing which were moving is his eyelids and eye. And he has written a wonderful book dictated just by eye movements. So same brain, he was in locked in syndrome. There is something called locked in syndrome. You are conscious, but you cannot respond. So there is a total dissociation of networks in the brain, like it happens in the dream. Your body is paralyzed so that you don't act on dream by paralyzing the serotonin system, by blocking the noradrenaline system, external information doesn't come, so that your acetylcholine brings out the internal memories, so that your information which you have gathered in the daytime, the information means the firing which is going on, is integrated with already existing synaptic strengths. Compared in that comparison, lot of visual imagery comes up, some of them is deleted, you will never see, some of them is preserved. It appears very simple when I am telling you, it is a huge process which is going on. And what timing it has to do? It has to block the serotonin, it has to block the, in fact there is something called REM behavior disorder, where this dissociation which happens, and this happens temporarily, 20 minutes it will be there and then back to integrated self. Where does the self go in dream? Physiologically, where is your self? What self you are talking about? Your hands are not moving, you are not acting out in your dream. So anyway, I will leave you with these questions, and so I will continue this in the last lecture of this course. Thank you and see you in the next lecture.